So in the previous video, we actually discussed some conventions for naming packages, but we haven't actually looked at what a package is yet. Now, if you think back to the abstraction challenge, which is now a few videos ago, I actually suggested that you didn't call your linked list class, the one that you were creating, your own linked list class. I suggested you didn't call that linked list because that is the name of the linked list class that actually comes with Java. But with that said, that was only a suggestion because it may have actually caused a little bit of confusion. So there isn't actually a reason why you couldn't have used the name linked list, even though Java's already used that. So I just want to open up a slideshow and just talk briefly about a few things. So firstly, talking about packages, things to keep in mind that there's over 9 million Java developers worldwide. So classes or interface name conflicts are going to be inevitable because the thing to remember is that people are going to use common words, so it's highly likely that you're going to find these conflicts. So as a result of this, Java were pretty well forward thinking, and there was a mechanism that was actually needed to fully specify the class, and as a result to allow use of classes with the same name in the same project or even the same class itself. So let's go back to the code and talk about that a bit more. So what we're going to do is just type a bit of code here just to show how these packages actually work. So to start with, I'm going to actually type node equals null, like so. And as you've seen before in the course, Java is going to come up and say, I've got some options for you. So if we select that, now look at all these different options that actually come up. There's actually 9 there. So there's actually a ton of different options that Java is actually recommending with the word node in it. So because this lecture is all about packages, you probably guessed by now that the mechanism I'm talking about to make sure that people can reuse names is actually called packages. So a package, think of a package as a way of grouping related classes and interfaces together. So the actual package mechanism provides a way to manage the namespace of object types, and it also extends access protection beyond the traditional access modifiers you've seen before, public, protected, private, etc. So we'll actually be talking about access in the next lecture, not here right now. So I've actually seen this come up before. When this does pop up on the screen, the normal response has been to import the appropriate package. So we go down and actually select the appropriate package. And obviously at the moment we've got an error. So if we go down here and actually choose, say, javax.scene.node, which is one of the nodes, that obviously gets rid of the message. And then automatically, as you can see here on line 3, the import line got added to the start of the line. Now that's just one option. That's one way of doing it. There's actually another option that you can use instead of using these imports. So we can actually delete that again, delete that out. And obviously that brings up the same error again. And instead of actually importing, we can come up here to the start of node and we can actually type in javafx.scene.node. And you can see at that point that Java is now happy and IntelliJ is happy because we've actually specified the actual package that contains the node class that we want to actually work with. Now the important difference here is, unlike the first situation just a minute ago where we saw the import statement come up on line 3, in this case the package is not imported. So what that means is every time you want to reference this node, you actually have to type it out. So you can see how that would really get tiresome really quickly, having to type javafx.scene.node and doing that for all your classes as you're actually using them. Now, if you're actually using 2 different node types in the same class, then you actually have to refer to one of them that way. So if we try to import the same class from 2 different packages, Java's going to give us an error when we try to compile. So if we actually want to put our imports in, we decide to actually use the import. So we do something like import javafx.scene.node, the first one, and we try and do this, import a second one, org.w3c.dom.node. Notice the error there already. And then even if we actually come along and put org.w3c.dom.node, another node, we've already got an error here. And it says javafx.scene.node is already defined in a single type import. So we've actually already used node essentially. So IntelliJ in Java is not going to allow us to do that and get away with that, even if we're qualifying our classes with the full, what is the package for that class. So what we could do then is therefore with the first statement, we could get rid of that package and just use the normal reference. So if I come along here and leave that as node now, I'm going to temporarily comment this out and we'll get rid of that second one. I just want to show you another way of doing things. So with that method, we can then come along here and we can uncomment that, and that's going to work fine at that point. So one of them is using the import, and the second one is using the fully qualified name pointing to the actual package that's actually got node. But noting again that we can't actually have two imports, so if you put the import up here, org.w3c.dom.node, we're going to get an error on the second line, and then IntelliJ starts trying to help us because it's a little bit unsure as to which import to use. So we're going to delete that, like so. So in summary, the javafx.scene.node can be referred to as node, as you can see in the code on line 10. But the second one, the org.w3c.dom.node, has to be fully qualified whenever it's used. Now you're actually free, obviously, to actually use the full name for both of them, and that can actually make it clearer as to which one you mean. So in other words, you can actually come up here and paste that into there. Oops, added an extra node there. And use both, and then obviously you can see IntelliJ's actually got rid of the imports. Now just in terms of those imports, just to be clear, some of that's happening automatically because of the way that I've actually configured the editor. So I want you to go into IntelliJ and go into Preferences. Now if we go to Editor, and there's a couple of ways of doing this actually. What you can actually do, I'm not sure whether I've actually mentioned this to you before, but you can click on a particular section and you can do a search, and it will actually give you a shortcut. So I can type in import, because that's the thing that I wanted to look at. And it will actually point out where that is. So in this case, it's under General, Editor, General, Auto Import. So that's actually the one I wanted. So if I go there and just to show you the options I'm talking about, you can see that we've got some options for our imports. We've got the Show Import pop-up, Optimize Imports on the fly, Add Unambiguous Imports on the fly. We can actually exclude from import and completion if for some reason we didn't want that to happen. But the one I actually want to talk about is Optimize Imports on the fly, because that's the one that's actually adding and then deleting imports as our code changes. I actually like to have that option on. And the reason for that is that it just cleans up your code. If you're no longer using an import, then IntelliJ is automatically deleting those, and that just makes your code a little bit cleaner. So I would suggest that you have the options for auto import in IntelliJ set to that what I've got on here. And notice also other languages, you've got similar options there to actually set for different languages depending on what you've set up, what plugins you've actually got in IntelliJ. So I'm going to leave that option there. Then the only other one here is ask. If you're pasting in a block of code, IntelliJ will come up and ask you which imports. That can be a good idea to do as well, so I suggest you leave that on ask. So I'm going to cancel out of that because I've already got my settings set. So basically you can see now if we've got more than one class of the same name, it can get a little bit confusing, or there's more work to do to make sure you know which one you're referring to. You either have to use one import, then refer to the second one of the same name by its fully qualified name, with the actual package name, or you need to just use all the references and actually have the fully qualified name, whichever you want to do. So just going back to our slides for a minute. Now, you might be asking now, why would I want to use packages? Well, some of the reasons that you actually want to use packages is that it makes it actually easier for programmers to determine that classes are actually related to one thing or another. The other great reason is it's easy to know where to find the classes and interfaces that can provide the functions provided by the package, because they're all sort of in the same group, if you will, or the same package. And the other important thing is because the package creates a new namespace, the class and the interface name conflicts are actually avoided as a result of that, because they're actually in their own separate area, which effectively is what that namespace is. It's sort of a different area that all these classes and interfaces are actually sort of put together or placed together. And importantly, classes within the package that you create have unrestricted access to one another, while they still restrict access for classes outside the package. So that's another sort of very important reason why you'd actually want to use packages. So let's go back to our code again. Now you may or may not have been aware of it, but we've actually been using packages throughout this course to date. One example is java.util.scanner. Now you've seen that in many programs, and that's the code that actually provides the ability to accept user input. And we've used that in quite a few previous videos. Now we've also imported java.util.ArrayList, and we use that in order to use array lists in our programs. And of course we've used array lists and other lists quite extensively so far. So basically it's actually impossible to create a Java program without using at least one package. And java.lang, for example, contains the class object that is used to support our classes, as well as integer and double, etc., and all the fundamental building blocks of a Java program. So that happens automatically when you create even the most basic of Java programs. Now you will actually not see an import for java.lang because it's automatically imported for us. Now you could import it. You could import, say for example, if you wanted to use an integer, you could come along and you could actually type import java.lang.integer, like so. And it's actually been removed automatically because of those the optimization settings in IntelliJ. But my point is you could do that, but they're automatically, for this base java.lang package, they're actually automatically imported anyway, and it's not something you need to worry about. Just in case you're wondering where all that code comes from. Any of the basic stuff like classes and as I said, integer and double, they come from java.lang. Now, before we actually create our own packages, which we're going to be doing, it's probably worthwhile to have a look at some of the other ones that are included when you actually install the Java Software Development Kit. Okay, so what I'm going to do at this point now is create a new project, and we're just going to go through a bit of a demo to solidify our understanding. So I'm going to type in select new project, select Java, create project from template, making sure command line app is selected. I'm going to call this one WinDemo. Doesn't really matter what we call it. But I'm actually going to type this one as com.example.awt sample. Now the com.example could be could easily have been com.timbachauka, but we're just going to use that as this example. Click on finish. We're going to use this window because we've got the other project open to close that, so I've only got this one opened. And what we're going to do then is we're going to leave this main class, we're going to create a new one. So we're going to come up here into source and into our package and new Java class. We're going to call it my window. And for that one, what we're going to do is we're going to write a bit of code that actually draws something on the screen. So we're going to type extends frame, and frame is the java.ort, as you can see there. And notice how the import went through straight away. And we're going to create a constructor, and it's going to accept a title as well. We've got frame, which accepts a title, and the title is going to show on the little window that pops up. So we're going to use that constructor. And actually, we'll get rid of this throws headless exception because we don't actually need that. That's just added by default by IntelliJ. So we're going to set the size of the window. Set size 500, 140. We're going to add a window listener. And I'll talk about these shortly, what they actually do. Window adapter. And window closing is the one we want. It's asking us which one do we want to override. We want to override window closing to do something when that closes. So I'm going to click on that. And you can see it's automatically come up with that code for us. But I'm going to change the super.window_closed and actually put system.exit. And essentially what we're doing there is we're just saying if you click on the close button in the window, it's actually going to override the standard function and actually close down the app, which, believe it or not, doesn't happen by default. We also want to override another one, which is paint. And this is a method that is actually called automatically to actually draw the screen. So we need to leave the super.paint in there. And this is only a few lines of code here just to show basically how these packages work. So we're going to create a font, sans serif large equals new font. Type is important there. Need to get the correct upper and lower case. Be font.bold 18, size 18. Now, just to be clear, the exercise is about packages and not about using the actual graphical side of Java, just to be clear. But we'll continue on. As sans serif small equals new font, sans serif again, and be font.bold, this time with a size of 12. Then we need G, which is the graphics object that was passed to this method, set font. And be sans serif large initially. Then I'm going to g.drawString, which is a mechanism to actually draw something on the screen. And I'm going to put the complete Java developer course. And we're going to position it at 60,60, like so. Then g.setFont, sans serif small, g.drawString by Timbachauka, 60, 100. You can probably guess now what this actual program does. And just to confirm, when we actually extended up here, when we actually extended by frame, you saw IntelliJ offer some suggestions, and I accepted the import, the top one, java.ort.frame. Now, I want you to notice that when we actually did that, did you notice how this first import that went through was java.ort.star? Probably should have mentioned that a little bit earlier, but I didn't type it like that. Whereas in these other things, when we use the Windows adapter and the window event, it's actually only imported those. But with the java.ort, it's added .star automatically. So we'll have a look at what that means and why later. But for now, we're going to use some of the other packages, as you can see, to create a very simple window. But we use some of the other packages, window adapter and window event, and we've created just a very basic window. So basically, this is just a standard mechanism to enable us to pop up something on the screen. So now that we've created that class, we can go back to our main method, our main class I should say, the main method within that, and pop this up. So let's do that. We'll call it my window. My window equals new my window complete Java, and my window dot set visible true. So there's actually the code now to actually run it. So we should be able to run this now, and it should actually pop up our little window. And there's our little example, as you can see there, very basic, but it is actually working. The actual name that I actually signed, the complete Java developer course, and obviously my name as well. So what's the point of all this? Well, if we just go back to my window again, can you actually imagine having to do this all automatically? You can see there's, relatively speaking, considering what's actually happened, there's actually very little code you actually had to type. All the infrastructure code to do a lot of this work is automatically in these various classes, these packages that have been provided by Java. So writing all this yourself, writing a window manager, something that actually creates fonts, that actually sets different fonts, that enables you to draw things on the screen, positioning it at certain places. That would be a huge undertaking to do something yourself, and it could be months or even years of work. But by using the Aut package, we can actually take advantage of the facilities that it's provided for producing these GUI programs. And just in case you're wondering, Aut, AWT, stands for Abstract Window Toolkit. Now, because that package, the Aut package, provides everything necessary to create the GUI interface, we know that we can actually find all the classes and methods that we need within that package. And the thing is that if Aut needs to be upgraded, new packages can be deployed rather than having to update files that are scattered around the Java SDK. So that's why packages are really essential. They can actually bundle these changes, and from your perspective, nothing really changes. You're still accessing them via the package. All the new code is actually happening, and it's all actually added to that package, making it a far simple exercise for you to actually work with. So this video is getting on a little bit long now, so I'm going to actually stop the video here, and in the next video we'll continue on talking about packages.